and then I'll give you part 1.
Sorry, I got confused with. I did this ahead, that's why.
Yeah, you're ahead. I'm impressed.
Like
All right, so they want me to figure. So this is more logs. It'd be kind of good because there's some logs on the stuff we're testing on today and tomorrow. So this is more advanced log properties. So how can we figure that log question out? Well,
76.
yeah. So you can just put an X over here. Remember what we've done for logs. This could be a log question on today's test. We didn't exactly do this, but really with the skills you already have, you could do this one. Just put an X on the right side, and then what you do is you lose the log. And what happens when you lose the log? Yeah, when you lose the log, you cancel the log. The base stays the base, and the other two switch. So, who's the base? Who's the lower down? Well, this guy. He's the lower down one. He continues to be the lower down one. And the other two. Now, what do I mean by other two? Everybody else. Everybody else. So that means this whole thing and that whole thing, they switch, don't they? Instead of the base to that stuff, X goes in that. Oops, it kind of jumped on me. X goes in that spot, and the 3 to the 76 goes to the other side. They switch, right? Now, isn't that the standard maneuver we always do when you cross out a log? Base stays the base, other two switch. And then so you tell me, what's X?
76.
It's all by observation, clearly. X has got to be 76. Yeah, so we see a lesson there that when the base and the thing right next to it, argument it's called, match, you can just cancel them out. It's just 76. They undo each other effectively, don't they? That, by the way, is the same reason that the L in a V is just 1, because what base is really there? E, and they cancel each other out. It's just 1. That's another reason why that's true. Whenever the base and the plug-in match, they cancel because of this truth right here. All right, so that's easy, huh? Enough to read it, probably. So ln E 18. What do you think? 18. Because there's another E it's not showing, huh? ln always has the lower down invisible base. They cancel, it's 18. I mean, you could do the formal X thing if you want, right? I'll do it real quick. If you wanted to be more formalistic about it, you could say, well, it's X. This has got an E down there that's not showing true. Lose the log, right? Base stays the base. Other two swap. E to the X is E to the 18. So what's X? 18. Or you can just cancel them out. 18. Good? So 5 to the log 5 of 3. Well, guess what's going to happen? What have we been seeing? That when the base and the power are the same thing, what do? Cancel. 3. I could show you more formally, but let's don't. I mean, come by office, I'd be glad to show you. But basically, they cancel each other out. They cancel each other out. When the base and the power match, they cancel each other out. That's what they do. They're the opposites of each other on that. Good? Good on that? So, yeah. I mean, yeah. Well, I could let... I just don't like doing math like it's magic, because it's not magic. It's logical steps. So let me. That's fine. If you on a test, that's fine. I'm totally fine. It's multiple choice, so it's fine. But let me show you formally. Why? Give me a real reason, Mister. I would, if I was you, I'd feel like, give me a real reason. Why is that really true? Well, to give you a real reason why that is indeed true, what I could do is I could bring in a new log that wasn't already there. And what happens whenever you bring in a new log that's not already there? You bring in a new log. When you gain a log or lose a log, the base stays the base. The other two. So I can just make that equal to X again. Just say you're equal to X, just to give it a name, like naming a pet. You're Rover. You're X. Okay? And then I could bring in a new log word, an extra second log word. You could always do that whenever you want. You could bring in a new log or remove a log. And whenever you bring in a new log that wasn't already there or remove a log that was, what happens? Base stays the base. Other two switch. That's the fundamental rule of logs, right? So if I bring in a new log word, the base will stay the base. Who's the base? That. He's clearly the low down one. Got something on him, right? He'll continue to be the base. The base stays the base. The other two will switch. What are the other two? Everything else. All of this and the X will what? Switch. Instead of 5 to that log stuff, it'll be 5 to the X, and the log stuff will go to the other side. Now you tell me Whoop, that was dumb. 3. What's the x? By observation. So there's a more formal proof, if that makes you happy. That makes me happy. I like to see a good reason why that's true. So anyway, but it's fine if you want to just cancel these out. It's 3. That's what it is. So powers and bases, when they match, they cancel. Why? Because a log is an inverse power. It's an inverse exponential, isn't it? That's exactly what it is. So they cancel each other out. Okay, log base 12 of 3 plus log base 12 of 4. All right. So now we're going to have 3 properties. There's 3 properties. Let me just give you the first. I'll write them all out later. But basically, whenever you have the log of any base of A plus the log of, well, let me write it the other way. The log base B of A, no, it's not going to, let me go x and y. Log base B of x times y is the log base B of x plus the log base B of y. Do you remember that property from your algebra days? That basically, maybe it would be good to write out all 3 right now. So property number 1 is if you have 2 things multiplied in a single log, that's 2 logs added. And then the second property says if you have 2 things divided, x over y, in a single log, guess what that's going to be for 2 logs? Subtraction, yeah. And the third property is really the greatest property. It's the one we've already used. If you have the log and you have a power, what can that power do? The Stalin-Hitler thing comes down to the front, dethrones it, takes it out of power. Like that. So there's the 3 log properties. Basically, this whole section 5.5, all 31 questions are basically using those properties forwards and backwards. Just wanting us to get more and more comfortable with those 3 log properties. And you've seen them before, right, in algebra? But we'll just, do them a little more thoroughly here. So everybody see those qualities. Basically, if you look at what's happening there, I want to give you could write them on a 3x5 card, but they'll be easier for you to use if you're more and more comfortable with them. If you think about it, what logs are doing, because they're inverse exponentials, is they're bringing everything down a level in the hierarchy of operations. What did all that mean? Remember, please excuse my dear Aunt Sally, or PEMDAS, or however you want to say it. The order of operations, right? Parentheses, and let's get rid of parentheses. We don't have any parentheses here. But basically, exponents, multiplying, dividing, adding, subtracting, right? Exponents like powers, 2 to the third. Multiplying and dividing, and then adding and subtracting. Well, it's 3 levels of operations. And the reason they're levels is because they repeat one another. Have I said this before? No? Okay. Right. 5 times 3, that is 5 added 3 times, isn't it? Multiplying is repeated adding, isn't it? That's what multiplying is. It's repeated adding. So that's why multiplying is a level above adding, because it's repeated, instantaneous adding. 5 times 3, 15. We just added 5 3 times that fast, right? Multiplying is a higher operation. It's a repeating of a lower operation. Same way division, 10 divided by 2, that's repeated subtraction, isn't it? That's like subtracting 2 5 times. It's saying, how many times can you subtract 2 from 10? 5. That's the answer, isn't it? So, dividing is repeated subtraction. Likewise, powers, what are they repeated? Repeated multiplication, huh? It's 2 times 2 times 2. That's why they're a level above multiplying. When you go 2 to the third is 8, you just instantly multiplied 2 3 times, didn't you? So, if you think about the operations in a hierarchy, the PEMDAS, as you learned them in school, adding, subtracting is the first thing you learned. Then you got older, did multiplying, dividing, and then powers later. Logs, if you think about it that way, they basically bring everybody down a level, right? Look right here. Multiplying becomes adding. It brought it down a level. Took it from multiplying down to adding. Dividing brings it down to subtraction. Because logs undo powers. They're the inverses of powers. That's what's going on. And then power becomes what? Times. Power brought it down to multiply. Didn't it? That's their greatest quality, as I've said. We have nothing else in the math curriculum that takes powers out of power. Real helpful to us. So there we go. So there's the 3 log properties. And another thing to help you kind of memorize. You don't have to memorize, but it'll be helpful to you. You can put them on your 3x5 card, but just knowing them cold is helpful. The harder operation is always for one log. What I'm talking about. One log, notice it's one log to two logs. One log to two logs. And then the third one is different. The third one's special, one log, one log. But I mean the first two properties. The first two properties go one log to two, one log to two. And how they do that is the easier job is for two people, the harder job is for one person. Like the old saying, many hands make the job lighter, right? You know, more people doing the job make it better. Had to move a 700-pound table this last weekend. My friend was moving, and so he said, we got a 700-pound table. So I came home and told my kids, I just moved a 700-pound table. And really there was like 7 of us guys that got around it, and that's why we could move the 700-pound table. So same thing here, right? So that's what's going on with logs. See, for one log, it's multiply. It's a harder operation. For two logs, it's the easier one. So it's always the easier operation for the two logs. Is that making sense? One log, it's divide. That's a higher level operation than simple subtraction. Easier for two logs. So it's always the easier operation for the two logs, harder for the one. That's how the properties work. All right. With all that said, let's do this question now. So what they're wanting me to add, see, easy operation for two logs. So I'm going to make it one log. And by the way, the base never changes. See how the b is just the same thing everywhere. You don't ever mess with the base. It's just always what it is, it is. Don't do anything with that. It's just what we're going to do with the 3 and the 4. That's the question. So what am I going to do for one log? So it's adding. It's an easy job. It's just adding for two logs. What will it be for one log? It'll be times, in other words, it'll be 12. And what's that? What's log base 12 of 12?
1. Oh my
Yeah.
God. So,
Right, do you remember why? You could call it x, right? If you want it formal again, you could say why? Call it x, lose the log, base is a base, other two switch, 12 to the x is 12, so what does x have to be?
Can you put it in the
1.
answer thingy so I can be sure?
Put it in
Can
the...
you put it in the
Are you
box?
doubting me?
Yeah.
Wow. Right. Did I flash off that too quick? I just felt challenged, I had to go quickly to the answer. Was that okay? Did I flash off that too quick? That all good? We good? Yeah, so you don't have to do all this X stuff. When the base and the plug-in match, it's always just going to be 1. That'll always work. All right. Let's try this one. Let me let you try. So go ahead. So it's subtraction for 2 logs. Subtraction for 2 logs. So easy, adding, subtracting are the easiest. First things you learned when you were a young math student, right? Adding, subtracting, that's the easiest operation, one of the 2 easiest, bottom level. Okay, so easy job for 2, going to be a harder job for 1 log. And what will it be? Subtraction connects with division because they both make things smaller, huh? And adding and multiplying connect because they make things bigger, right? So it's going to be 30 over 6, just this over this. The base doesn't change. We never mess with the base with these properties. Is that good to there so far? It's just going to be 1 again, isn't it? These are all just 1. I don't know if they're all just 1, but that one's 1. Good on that? Rest of a property we've already got in our backpack, something we can do. Let me show you, let me remind you. Log base 4, 7, log base 7 of 64. Okay, so here we go. Log, they're multiplying. 4 times 7, 28. And multiplying, we can add them like that. That's all garbage. But I want you to see that's garbage first off. Does everybody see that's not right at all what I just did? I'm just making stuff up now. But it's important to see that's, because I know when this stuff's new, it's all confusing and weird. But I think it'll help. To write something wrong and point out why it's wrong will be instructive, and then I'll do it right. So first off, that's just not right. There's no rule that says you can multiply bases. That was, first off, super crazy, right? You can't do that. The bases never change, so that's totally wrong. Just the fact that they have different bases is a huge alert right away that it's not any of those 3 properties. I'm going to do this problem a totally different way, something you already know. Remember, I'm going to divide the 2. Remember how we learned that you can make this log 7 over log 4? That's what I'm going to actually do, which is something we already have, and might use today or tomorrow. I can't remember which one. Remember, that's what I'm going to actually do. I'm not going to use either of those three properties. Why? What's letting me know I shouldn't use those three new properties? They have different bases. All those three properties I gave you, bases have to be the same. We never change the base. So it's not that. This is craziness. And you don't add these. This is a times. This is a harder job, right? Times, multiply, divide are harder operations. It's a harder job for two logs. You don't make that easier for one. That's backwards thinking, right? So that's not right either. But everybody see that difference? That's backwards. It's the harder job for one. Harder for me to lift that whole table myself. Easier when a lot of people were there, right? Not vice versa. That's craziness. So coming on back here. Well, then what do? So it's not. So you notice it's not the new three properties, especially because the bases are not the same. That's what really clues us in, right? Those bases are not the same. You have to have the same bases for those properties. Okay, well then what do? Well, what we learned, remember how we learned that whenever you have a log, anytime you want to, you can make it into two logs, and the high goes high, the low goes low. I say that because people in the past had trouble remembering which one was on the top and bottom. So it's not first, second. Just let the higher one be high, let the lower one be low. Remember that? You can do that anytime you want. Anytime. Anytime you want. You can make one log into two, like that. And this one, same thing. Again, high goes high, low goes low. Now, why is that so great? Well, because then those cancel, huh? That's just cross-canceling. Multiplying two fractions cross-cancel. Okay, why is that so great? Now you have log 64 low. You could just hit the buttons on your calculator, but it is 3. It'll come. You could prove by a log way, but let's just do our calculator. 3.
As in 4 to the third, 64.
Yeah, that's what it is. That's really the deal. Yeah.
So if you plug into your calculator,
Mm-hmm.
and
Yeah, you can just plug in. Oh, sorry. Go ahead.
if you have a different base other than like just natural log 10, how would you plug that in? Would it be natural log?
Yes, you mean like for any old kind of log, like if you had log base 4 or 7, for example, and you wanted to get, you would literally just do the high goes high. You type in 2 logs in your calculator.
Okay.
Just like that. Yeah, and that's important because we needed that a little bit on the graph ones sometimes. Yeah, so that might be, I don't remember off the top of my head, something you might need to do today on, if you need to figure out some weird log base, you turn it into 2 logs on your calculator. Yeah, that's exactly. Because remember, your calculator can only do log base 10 and then ln. Right, those are the only 2 your calculator can do straight ahead. So if there's any base like 4, some base other than 10 or e, you have to turn it into 2 logs. Right, we talked about that on that. That good? So we can do one more. Okay, so notice that's all up in the power. All this is in the power. So let's just grab that all by itself first off and think about it. Log base 3 of 1 minus, let's just look at the power first off. Log base 3 of 1 minus log base 3 of 4. Can I do something with that? Is that one of the property things? Is that one of the 3 properties?
Yeah.
Yes, the bases are the same, so that's good. And it's subtraction, which is an easy, adding, subtracting are the easy operations, easy job for 2 people. So then, yeah, that fits. It would be a harder job for 1 log. It would be, subtraction would go to what? Division, be 1 over 4. For 1 log. Harder job dividing for 1 log. Good so far? So the power becomes that. So this question becomes 3 to the log base 3 of 4, right? That all becomes the power. Going too quick? Is that good? And then what is that? 1/4, right? These guys just cancel. Remember when the base and the power just cancel. 1/4. Is that good? Should we